Now let's take a look here at example 6. And so on example 6, here's some rules that are showing you of rationals, how the limit will work when we approach positive and negative infinity. We gave these rules in lesson 2.5, and you might remember that we have 3 rules, and the rules that as we described them in acronym form or EATS-DC, that if the exponents are the same, you will divide your coefficients. The horizontal asymptote is the same rules for your limit as you go to the right and the left will be your asymptote rules. So where we had exponents are the same, divide coefficients, that'll still be true. If it's bigger on the bottom, then it'll be 0. Bigger on bottom, y equals 0 was our asymptote rule for in behavior or limits. It'll just be 0. And then if it's bigger on top, there was no horizontal asymptote, but for us, you could say bigger on top, it'll either be positive or negative infinity. So I'll just do big bot plus infinity. So that these are going to be our rules. And so the power is the powers and the fraction are the same. You'll divide your coefficients. If it's bigger on bottom, it'll be 0, and if it's bigger on top, it'll be plus or minus infinity, whichever, depending on the direction here. So as I look at this one, the powers of this rational function are the same. The exponents are the same. So I will divide my coefficients. This was all on lesson 2.5. Let me write that in the notes. Lesson 2.5 here. So I'm going to divide my coefficients. So this limit here will be 2/3. The limit as x approaches negative infinity of 2x plus 1 divided by 3x minus 4 will equal 2/3. And so as you see this graph, it has a 1 there. It shouldn't. This graph itself, as you go left forever, as you travel left forever, you'll see that there is this asymptote on this graph, and it's below the value 1. So 1 is actually not a good answer here. It's actually approaching this value of 2/3. That's the value right there that this graph, as you go left forever, is approaching. So 2/3 would be our solution here. Part B, I look at and I see that the power is bigger on the top. This one's bigger on top. So if it's bigger on top, I'm going to say the answer is going to be plus or minus infinity. Now, how do you know? This one is typically going to be viewed as if this is a shortcut here. But if you divide your leading terms, 2x cubed divided by 3x squared, and specifically ignore the coefficients, I'm going to say that's roughly going to be 2/3. I said ignore my coefficients, I just wrote them. 2/3 the x1 power. I shouldn't even say approximately because that's not true. So I'm just going to do one little squiggly line. Now this function, if you plug in a positive infinity, that's going to look like a line. And so if you think of a line, and we want to know as we go right what's happening, the value is going to increase to positive infinity. So I'm going to go ahead and estimate that this increases to positive infinity, but let's go ahead and see it as a graph. So if I wanted to look at 2x cubed minus x squared, x squared over 3x squared minus 1. And as you zoom out, you'll see that it does look somewhat like a line here, which means that as we go right forever, it does increase forever to positive infinity. Now let me put in the line 2/3 x. When I divided by the leading terms, I got 2/3 x. Wow, look at that. It's almost as if math works. Oh, it does. Math does work. Math is a truth teller. It tells the truth. That works. So yeah, it approximately is 2/3 x. And so as we go right forever, as this graph goes right forever, that's not what I wanted to do. Let me try this again. Right forever. The y's go up forever. And that's kind of the pattern there. So now let's see this one. I'm looking at the leading terms. It looks like here's my leading terms right there. So this one, the exponents are the same. Exponents are the same. So what we'll do is we'll divide our coefficients. So the answer is actually going to be 5/2. So all this would equal 5/2. Let's check just to make sure. 5x cubed plus 2x squared minus x plus 1 over 2x cubed minus x squared plus 3x minus 2. As we want to see the graph as it goes right forever, I can see it's approaching a constant number. And if I put in 5/2, y equals 5/2. If I put that in and zoom in, you'll see that these lines are basically one on top of the other. There is very little difference. And the farther right this graph travels, the more and more true this would be. Let me go x value to. Okay, now that I'm way out here, let's zoom in. And so the closer and closer I see, or the farther and farther right I go, the closer and closer these two graphs will appear. And you can see I am so far in line here that they don't even show me another value on the graph. Like they're not even labeling this anymore. Kind of gives you an idea how close together those values are. So the answer would be 5/2 here. So here is one for you to try.